and welcome to the Swine Disease Reporting System. This is the report number 62. We're going to cover the findings from the previous month, the month of March. My name is Edson Magalhães here at the SDRS studio.
Hi, I'm Giovanni with the SDRS.
Hi, my name is Guilherme, also at the SDRS studio.
Hello, Daniel Linhares, also with the team.
And today, like I mentioned, we're going to cover the findings from the previous month, the month of March, for the SDRS project. But also, we're going to have a discussion with our special guest that we invited. We have the pleasure of having here today with us Dr. Maria Clavijo, joining the SDRS podcast. Dr. Clavijo is a research associate professor at Iowa State University and health assurance veterinarian at PIC. Dr. Clavijo, she got her DVM from the Universidad Central de Venezuela and her PhD at the University of Minnesota. Currently, Dr. Clavijo research group has been working with swine pathogens, including Mycoplasma pneumoniae, Mycoplasma urines, and today's podcast main topic is on Streptococcus suis. Dr. Clavijo, thanks for joining us and welcome to the SDRS podcast.
Thank you so much for having me, guys. It's a pleasure.
Thank you, Dr. Clavijo, for being here in the SDRS podcast. Guilherme, could you provide us an update from the March, what we have been seeing in the SDRS?
Yes, let's start for the first page for the PRRS virus that even though we had like an activity below the expected in the weeks of the March 6th and March 13th, the overall percentage of positive submissions was similar to February. So around 25% of positive submissions, the overall. But at the state level monitoring that we have these state levels baselines, Kansas and Ohio, they have an activity above the expected for the month of March. And when we move to the sequencing part for the L1C variant scenario that we're keeping track every month, in March, we have this continuous report from East states having this sequencing detected over there. And one example is Pennsylvania, that we have 3 sequences coming from there, and also Indiana. But nevertheless, it is important to inform that the concentration of detections continue to be the Midwest states. And I would like to highlight the Missouri situation that we are having the highest number of L1C variants detection in the month of March, with 7 sequencing positives from the L1C variant coming from Missouri. And also it's important to notify to our audience that we had 2 sequences coming from sow farms in the Oklahoma state from the L1C variant.
And what the advisory group has been telling us about that?
Well, our advisory group highlighted that they have some possible dissemination sources for these states that are contributing to this increased detection over there. And one of them is the closed sow market, moving positive animals to these regions. And also movement of animals from multipliers that do the replacement over there, and somehow they can like introduce positive animals as well for the L1C variants. And trucks coming back from packing plants that are possible sources of dissemination of these variants as well. And the advisory group reinforced that the importance of biocontainment and bioexclusion practices to avoid the dissemination of PRRS in this specific region and also in the whole US. And also the importance of testing animals, not only gilts, but every animal that is placed in a different site to see if these animals are positive or not, and do the follow-up through the weeks as well to confirm that these animals are really negative animals that we're introducing in this area.
So in sum, biosecurity and biocontainment practices should be always in the radar there.
Of course, yes.
Anything from the enteric coronavirus there?
Yes, from the last episode, we said that TGE was close to complete 2 years without any detections in these 5 VDLs that we have enrolled in the SDRS. And now we have the pleasure to announce that in March 23rd, TGE completed 2 years without any PCR positive cases in this SDRS network of labs that we have. And also, but now moving to the Delta coronavirus is kind of the opposite. We are having an increased detection right now in the month of March. And just to have an idea, when you look to the historical data, usually it's 4% of positive submissions that we have to this period. And now we have the double with 80% of positive submissions. And since we look back to this historical data, we start to notice that every 2 years, we start to have this cycle of increase of Delta coronavirus that is going on. And so it happened in 2018, it happened in 2021, and now it's happening in 2023 again. And looking to the state level submissions again, South Dakota, Minnesota, and Kansas regarding Delta coronavirus, they have an increased activity compared with the baseline.
What the advisory group has told us about this activity of Delta coronavirus?
Well, for the specific month of March, they said that the cold temperatures coming from the winter like contribute to this virus to still like persist in the environment. And also the production system have more problem to washing and disinfecting facilities and trucks. So that's contribute to have this virus like going around in the sites. But regarding the cycles of every 2 years of we have this increased detection of Delta, they mentioned that more investigations must be done. Mainly to the role of the feed ingredients, wild animals, and also serological status of the farms to see if these can contribute to these cycles occur every 2 years.
So it seems like we still need to further explore what's going on there, that we are having this increasing detection of Delta coronavirus at the month of March. So when you move on for the other pathogens that we have for PCR detection, PCV2, Mycoplasma pneumoniae, and influenza, any information for those ones?
Yes, for the Mycoplasma specifically, we still have a continued increased number of total cases. We do not have a high activity of positive cases, but when we look at the historical data, for example, in 2022, the monthly submissions for Mycoplasma was around 600 submissions. And now in 2023, we are having 800 submissions per month. So it seems that they are monitoring more for this specific pathogen. And moving to influenza, we are starting to have an increased activity mainly in the winter market category. And this is expected based on the SDRS database. We also identified that the spring and the fall seasons, we kind of have this pattern of increased detection of influenza every year. And moving to the PCV2 situation, I would like to remind that in January, we informed that we had an increased activity in the winter market category, this high activity, but it was concentrated only in the Iowa state. And now in March, when we looked, we have a marked increase in the number of positive submissions coming from South Farm, and also a drop in the average CT values of these submissions. And these are coming from all the states that we're monitoring for PCV2 specifically.
Well, that's interesting. PCV2 coming back from South Farm, so something may be there. Any comments from the advisory group for SDRS?
Yes, they highlighted the importance of vaccine compliance and effectiveness. So try to always do the full dose, like not only that you have dose, and investigate if this might be causing this increased activity in terms of vaccination. And also the PCV2 genotype B that might be circulating in the field, and most of the vaccines that we have in the market today do not cover this specific strain.
That's great. Thank you for providing that feedback for us, Guilherme. And just one more comment that we have there is that PCV2 is also making up on the top 10 disease diagnosis list this month from the Iowa State University. So something may be going on there that deserves further investigation.
No, very good. Well, let's move on to our discussion with Dr. Clavijo. Especially here today, we're going to focus on strep suis. Dr. Clavijo, so focusing on strep suis, we would like to know the overall situation of strep suis in the US, in your opinion. And as a health assurance veterinarian, how often do you deal with strep suis clinical cases, and what's the impact on the swine industry?
Right. So strep suis is the #1 endemic bacterial agent we struggle with most at the multiplier level, realizing that our multipliers are negative for Mycoplasma pneumoniae, right? So this is likely the main bacteria that we deal with in our farms. So as a reminder, this agent causes meningitis, arthritis, serositis, septicemia, and it's not uncommon to see between 2 to 5% of the mortality attributed to strep suis. And in outbreak scenarios, you can see upwards to 10% of mortality attributed to this pathogen. This agent is typically regarded as a secondary agent, meaning that we tend to see it a lot more when we have outbreaks of influenza, outbreaks of PRRS, even with Mycoplasma pneumoniae. I've had several cases of multipliers where we finally get the strain, the strep suis strain from the herd after a myco break. Mm-hmm. So that's definitely something that you see an uptick of cases when you see strep suis. However, what's interesting to note is that we continue to see strep suis disease in high health herds, suggesting that frequently this agent creates disruption of the health status of farms without these viral or other, triggering agents. So the question is, why is that, right? And I think it's important to remember the epidemiological triad or triangle, that we know that the agent, host, and environmental factors interrelate in a variety of complex ways to produce disease. So, different diseases require different balances and interactions of these three components. So if we focus specifically on strep suis, given that it's an endemic agent, or in other words, it colonizes pigs, we see that a certain management factors such as poor ventilation, high stocking density, fluctuations of temperature, commingling different flows, definitely is associated with outbreaks or increased cases of strep suis. However, in other instances, the balance shifts over to not environmental, but pathogen. And we definitely see herds that carry a pathogenic strain or a highly pathogenic strain that's basically what drives the disease. And of course, like I just mentioned, other viral or bacterial agents that destabilizes that immunity, and strep suis takes a hold of that and causes disease. So to summarize, the development of appropriate, practical, and effective prevention and control measures will require the assessment of these three buckets, not only the host and building that immunity in the host, also is understanding and characterizing the agent, and then finally controlling these environmental or management practices that we know are associated with disease. And for us at PAC in particular, it all started with the right characterization and sequencing, let's say, in-depth characterization of the agent using next generation sequencing. Now putting my Iowa State VDL hat on, we wanted to understand how much of the agent we were diagnosing at the VDL. So in collaboration with you guys, in collaboration with the great team of pathologists that we have, and with the expertise of Dr. Ana Paula Silva and her statistical background, we went into an in-depth characterization of the frequency of detection and disease of strep suis over the last 5 years. And I just have a couple of, nuggets here of information I think your users, or your listeners rather, might find interesting. So strep suis accounts for 22% of all cases with an infectious etiology. So think about every single case that has an infectious etiology that is submitted to the VDL, 22%, so a fifth of them are strep suis. Not only that, it's out of all neurological cases, 70% of those cases are strep suis. So when you think about neurological disease in your herd, strep suis needs to be at the top of your list. That is equal to about 350 cases a year, with more of an increase over the last couple of years. So think about it, we're diagnosing strep suis at least once a day at the VDL. And then finally, about 30% of all infectious arthritis are also due to strep suis or diagnosed as strep suis disease, and about 20% of serositis cases. That's an interesting point. So we typically think about strep suis as a meningitis and arthritis causing agent mainly, but what we're seeing is still, not only does GPS and hyorinus cause polyserositis, we also need to think more about strep suis being the trigger for that disease. And then while arthritis and meningitis cases remain steady over time, we actually saw a significant increase over time of bronchopneumonia cases attributed to strep suis, and then endocarditis cases. So those are the two latest diseases that we're seeing more strep suis involvement.
Mm-hmm. Thank you, MJ, for all those information from the field and from your both of your hats, right? The field and the researcher hat. Can we dive a little bit on that? Because we know that you're not just observing, you were very actively involved in a lot of great applied studies on suis. What can you share about that with us?
Yeah, absolutely. So again, putting my breeding stock company hat on, I would say that for us, we're the pyramid, right? Everything that we want to do of improvement of health needs to start at the top so that it can trigger down or trickle down to the rest of the stakeholders. So in that sense, we are always looking for ways to control, prevent, and eliminate diseases. So, you know, one of the things that we've been working on is trying to eliminate some of these endemic agents that contribute to a lot of our dependence on antibiotics. And the logical one to think about is strep suis. So what we wanted to understand is, how does pathogenic strep, so I might make a little parenthesis here, strep suis is a very varied species. So you can have anywhere from commensal, let's call them opportunistic, non-pathogenic streps, all the way to highly pathogenic streps. There's actually a lot of science behind this and how these subpopulations are quite, you know, at the genetic level, pretty different. So we wanted to understand how these highly pathogenic strep suis strains move between pig populations. And we focused on the period that we can make a change, or we can modify or affect, to break that transmission and try and establish new negative herds. So that's kind of the context around this project that we did. So what we ended up doing is trying to describe the dynamics of disease-associated strep suis in the lactation phase. So focused on sampling piglets and sows using a novel marker, so strictly a tonsil, a nasal, or other samples in the pig, to see if we can directly use a PCR to say, does that swab have pathogenic strep or not? Again, we're not looking at the entire species, right? Because every single sample would be positive. Again, it's a colonizer. It's found in many parts of the body of the pig. But we wanted to only target in subclinical or, you know, otherwise healthy pigs. How is this transmission of these pathogenic streps happening? So understanding, again, the epidemiology of pathogenic streps would allow us to refine control and prevention programs for this pathogen. And the next part, more applied, is, well, once we know how the dynamics of infection occurs, producers and veterinarians will want to figure out what the best sample type is to target, to make these investigations at their level, right, at their in their farm. So we wanted to describe the detection of disease-associated streps in different dam-related samples and piglets. So identification of more sensitive, easier to collect samples would facilitate tracking of pathogenic streps. So I'll run through quick take-home messages from this. Essentially, number one, we now at the VDL have onboarded and validated a novel PCR that detects pathogenic streps that can be used in antemortem samples. The next thing that we found was that there's clear differences between distribution of DAS between parity groups and farms. And the basic take-home messages here was that gilts and gilt litters had a higher level of strep suis, pathogenic strep suis. What does that mean? It means that control programs targeting the gilt, so effective gilt acclimation, colostrum management, antimicrobial use, might be an effective way of minimizing pathogenic strep on the farm. And then we also saw some interesting things on the piglet side. So not everybody is weaned positive. So you have a big proportion of piglets that are weaned negative. And the question now is, does wean status predict disease? Is a positive animal less likely or more likely to be affected by disease post-weaning? And then the other interesting point that we saw was a dip at 7 days post or 7 days of age. We saw that the prevalence in both herds decreased. And what we take from that is that there might be the initial detection that we saw at birth does not necessarily mean infection. It just means you're finding it. And really what you're capturing at 7 days does reflect infection, or you're having some sort of effect on colonization from colostrum. So I probably missed it, but what we ended up doing was following sows and their piglets over time and sampling them at 4 different times. And these are kind of the things that we're trying to say, is that gilts versus older sows were more prevalent, and those litters from those gilts, again, more prevalent than litters from sow herds. And then what I just mentioned about carriage in piglets. And then moving on to sample types, we did find something really interesting. When you typically see the literature, tonsils are the way to go for antemortem sampling. And what we discovered is that nasal swabs might be equally as good, if not better than tonsils, to identify pathogenic streps. So again, think about doing nasal versus tonsil, a lot easier to collect nasal. So that might be a better way of, doing these investigations in the future. But we also found strep suis in the environment of the farrow, in the farrowing crate. We found it on the udder of the sow, highlighting that transmission of pathogenic strep, vertical transmission, might be happening in these areas and not necessarily contact nose to nose. So, that's our kind of the main findings. I don't know if you have any questions.
Thank you for the quick download of all that information. Just a quick question follow-up is, you mentioned gilt acclimation. How can people acclimate gilt for suis?
It's such a easy statement to say, right? Like, oh, we need to acclimate, do a better job of acclimating gilts. And Daniel, the bottom line comes down to it depends on the agent. For some, we have vaccines for it, and for other agents, we don't. For other agents, we know that feedback, like Rhoda, is very effective at gilt acclimation. So in particular for strep suis, I think there's enough evidence, field evidence to suggest, and empirical evidence to suggest that vaccines are effective for strep suis. So I think that a combination of strategic medication on piglets, and then on gilt, it would be pre-farrow vaccine, and then also during their development. It would be the two ways that we're mainly, acclimating gilts for bugs, but more work definitely needs to be done in that area.
Hey, Dr. Clavijo, you talk about this diagnostic process, using of next generation sequence, and all of those things that come along for these strep diagnosis. I'll be curious, what are your thoughts on how to build a diagnostic process there that would be confident that streptococcus is the cause of disease there, and what interventions could you apply on a farm on a daily basis?
Right. No. So about 4 years ago now, a producer came up to us and said, what are the strains that you have of strep? And we were kind of left like, what? Yeah, I know I've had a serotype here and a serotype there, but we really invested a lot of resources and time to understand the distribution of strains using next generation sequencing. So you asked a question about how do you know you have disease in your herd? I think once you think about the diseases that these bugs can do, like meningitis, arthritis, septicemia, cercitis, you do a really good job at targeting acutely infected, non-treated, I would say 2 or 3 to 6 pigs per flow. I also always recommend taking your thermometer with you and actually collecting pigs that have fever. We've learned a great deal, or I've learned a great deal from the pathologist on what are the best samples to collect. We would avoid lung, reminding the audience that lung has a variety of isolates, and it's most likely that you get the wrong isolate if you take lung. So you would want to target those tissues that are related to that disease, right? So if you're seeing polycerositis, take serosal surfaces. If you're seeing neurological disease, take CNS samples. In that sense, intact head is better. If you can't do that, sending cerebral spinal fluid is really good. We've actually collaborated with SMEC and put some videos on the VDL, and you can access those and see how to collect that sample. And then finally, meningeal swabs. Avoid collecting the meninges and sending them. Why? You can contaminate easily. And if you contaminate, you tend to grow the wrong strain, because non-pathogenic or commensal opportunistic strep suis are much hardier, robust. They grow easier. So they tend to outgrow the pathogenic ones that are smaller, let's say, less able to grow in these environments or these plates. So I said target the lesions, target the tissue that you're seeing lesions, right? If you're seeing arthritis, send the intact leg, better than trying to open up that joint and creating that opportunity for contamination. What else? I think, your whole process of shipping, include fresh and fixed tissue. Do not mix lung and meninges in the same bag, because again, you can have that cross-contamination of isolates. Always include the history and metadata, refrigerate your samples, and then be patient. For some herds that are high health, that rarely see strep suis, trying to get the right strain takes 2 or 3 attempts. For GPS, for Glasarella parasuis, even more. So I think it's not unreasonable to think that you're going to be going back to that farm probably 2 times to try and get the right strep suis strain. And then you follow that up with serotyping and virulence factor PCR. And once you have those 2 pieces of information, you can go ahead and do next generation sequencing. These 2 PCRs, or serotyping and PCR based on virulence factors, can alleviate some of the cost, meaning you don't end up sending to NGS the wrong strain and wasting money on that. So that's kind of like the thought process that we do on diagnostics. But then on interventions, great question. On interventions, there's 2 things that I like to think about. There's your emergency treatment. Okay, I have an outbreak or I have an increase in cases. What do I do? 2 things. Emergency treatment, which would be either you do an intramuscular, ceftiofur or Enro, Endexa, and you can do that in pigs that are showing clinical signs. And you can follow that with some penicillin, amoxicillin via oral or via water of the affected groups. And then also think about doing potentially as a prevention something at weaning, some sort of, again, an exceed at weaning could be something that we think, or an Enro at weaning or ceftiofur at weaning could be something that we think about. So that's kind of an emergency treatment. But at the same time, when you're seeing these increases in cases, you want to take samples again and run through what we just mentioned about diagnostics. Do you have the right strain in your vaccine, or do you have a introduction of a new strain? So what we just mentioned. So that would be one bucket, emergency or diagnosis and treatment, let's call it, of emergency cases. The next one is one that I like to refer as the immunity challenge balance. So in one sense, you want to maximize immunity, and on the other, you want to minimize challenge. So on maximizing immunity, what we just talked, Daniel, it's gilt acclimation, it's use and building that immunity in the sow, passing that good colostrum to the piglet. We also like to avoid anything of long-term effect on the piglet, meaning like a long-term acting drug before 14 days. Why? There's a theory that we want piglets to get colonized by pathogenic streps under colostrum immunity. So they build that active immunity. And once they're weaned, immunity goes down from mom, but they've already started to gain that immunity from being exposed in the lactation phase. If we go in and do something that affects that transmission under colostrum immunity, the pig is weaned not only without maternal immunity, but is weaned now without creating its own immunity. And you can see an increased cases. So again, no science to show that yet, but we definitely see that using maybe a short-acting pen earlier and within 14 days of age is what is better than a long-acting drug. So what was the next step? So, you might want to do some sort of prevention medication, some pulses, or some medication, oral medication in nursery, maybe something that you do prevention, an injectable at weaning, but it's that, maximizing immunity and minimizing challenge. The last thing would be to manage groups all in, all out, and then minimize any environmental triggers, temperature fluctuations, commingling of herds. I know that's harder to achieve. And then humidity, maintaining that humidity low.
Very good discussion.
Yes.
Really good. Thanks, Dr. Clavijo, for participating and bringing all this information. Very, very helpful, very good. I'm sure that our audience will be glad. I was just recently in Brazil, and it's a big issue also. Strep suis now there, so it's a good topic. And thanks for bringing all the thoughts and ideas. And I see you guys next month. Thank you.
Thank you.